So today we'll start our next chapter, that is chemical kinetics. So this chapter is very important for JAM, NET or GATE exam. So today we'll do for some previous year questions from JAM examination. Okay, we can see two questions in every year. So that came from chemical kinetics. So that's why it's a very important chapter actually for exam perspective. Okay, so we'll cover from 2018 to 2021 from in this video. So let's start this video. Okay, so our first question that came in 2021. Okay, so question is, half-life of a chemical reaction varies with initial concentration of A0. Okay, so A0. So we know that our first point, that for a first order reaction, reaction T half doesn't depend on depends on does not depend on A0 or initial concentration. Okay, so this cannot be the order of one initial concentration. Okay, so this cannot be 1, so our option B is not correct. So options are 0, 2 or 3 are, that is, are remaining. Okay, so a general formula, we know that a general formula for T half for any order of reaction, general formula of T half of order of n, okay, that is 2 to the power n minus 1 by A0 to the power n minus 1 kn. That is our general formula. Okay, this is a general formula. So from this we can derive the formula of T half. You just have to remember that last result, don't have to remember that that derivation, because it's a lengthy process, not lengthy process, but you just remember the result one. Okay, from here you have to derive our needed equation. Okay, that is, so T half of 1 means I am saying that T half of 2, that is means T half 1 is when the initial concentration is A0 1, and T half 2 is when the initial concentration of T half or A0 2. Okay, so that is 2 to the power n minus 1 by A0 to the power n minus 1 of 1. Okay, n minus 1 kn by same in 2 to the power n minus 1 A0 to n minus 1 kn. So just a minute, okay, now I can see clearly. Okay, now this will cancel out, n minus 1 cancel out, kn cancel out. Okay, so in our hand, T half 1 by T half 2 A 2 n minus 1 by A 1, so that is 0 actually, sorry, 2 0 1 n minus 1. Now we'll take log in each side, so log of, so t half 1 by t half 2, that is n minus 1 a 0 2 by, sorry, that is log of, okay, log of a 0 1, okay. So this is our, and n is order of reaction, n is order. So this is our needed equation, okay. You just have to put just any of two data, okay. You will use the first two data, okay. If you do, the first data will be first two datas, okay. So n will be 1 plus log of, sorry, that is log of t half 1 by t half 2 by log of a0 2 by log of a0 1. So just put it 1 plus log of, what are the equation, that t half 1 is 360 and t half 2 450, okay, 360 by 450, okay, by log of, that is 5 into 10 to the power, that is 2 by 1. 2 by 1 means 4 into 10 to the minus 2 by 5 into 10 to the minus 2. So 10 to the minus 2 is cancelled out, so 4 by 5, that is 4 by 5. So 1 plus log of, that is 9 to the 4, it is 5. So log of 4 by 5 by log of 4 by 5. So they are cancelled out. So 1. So 1 plus 1 is equal to 2. So our order of this reaction is 2. 2 is the correct option. Okay. So next question is, oh, this is a very came in JAM 21 and it's a direct question. Direct question means this is a very consecutive reaction, means A to B to C, we know that, and here K1 K2, just that. So we know that what is the C0 is the initial concentration of X, means here it is X to Kx, sorry, you don't have to write this one, here it is, okay. So initial concentration of C0, okay, and concentration of X, Y, Z at time t, that is Cx, Cy and Cz, okay. The expression of concentration of Y, from that we know that if this is the reaction, so B concentration we know, that is K1 by A0 by K2 minus K1 e to the power minus K1t minus e to the power minus K2t. These are equation. So we just relate this equation. So here it is Y. You just need the expression of Y. So that is Y K1, here K1 is Kx. Kx, A0 is the concentration of, initial concentration of A. So here it is C0. So C0, K2 minus K1. K2 is Ky minus Kx. Ky minus Kx, that is minus K1 means Kx t minus e to the power minus Ky t. So this is our equation, okay. So we just Cx, so this two option is not correct. Here C0, here C0, So you just need to relate e to the minus kx to. So here you can see it's a y, but here start with x. So this is our correct option A. Okay. So next question that came in JAM 20. Okay. So what is the question? This is a graph type question. The reaction scheme 1, the concentration profiles are there. Okay. This is the reaction. Okay. So these are the graph of this reaction. So you just have to what is the correct condition? Just need to know what is the correct condition of these reactions, and this is the graph profile. Okay, so here we can say this is our starting material. From here S is the one is creating, and here Q is producing, and from there P is. So we can write as a R to S to P, and another reaction is R to Q and P, that is K1 rate constant, K3, here K2, and here it is K4. So these two reactions are consecutive reactions. Consecutive reaction 1, consecutive reaction 2. It's like consecutive reaction. Okay, consecutive reaction. Okay, and another we can tell also that this from here S is producing and Q is producing. So here S, it is Q1 and K2. Okay, so we can tell this also parallel reaction. Okay, it's a parallel reaction. So for parallel reaction we know that for parallel reaction we know that K1 by K2 is equal to concentration of S by concentration of Q. Okay, so here from the graph we can tell that K1, if K1 is equal to K2, so at a time t S is equal to Q. So but we can this is concentration of Q, and this is a concentration of S. Okay, and this is a graph of R is continuously gradually decreasing, Q have a peak of peak, and S this one. So at time t, I am considering this is a time t, at time t this is the concentration of Q. Okay, that corresponds to K1. Okay, rate constant, and this is the concentration of S, that corresponds to K2. So K1 is greater than K2, K1 is greater than K2. So it's not equal, because at time t the concentration of Q is greater than the concentration of S. So K1 is always greater than K2. So this option K1 is equal to K2 is option, it doesn't correct, and this also not correct, because K2 is not greater than K1. K1 is greater than K2. So we have to know the other options. Okay, go for other option. So here K3 is greater than K1. K3 is means this one. For consecutive reaction which we read here, so where B max means from this question we can tell that if K1 is greater than K2, okay, and another condition is when K2 is greater than K1. If K1 is greater than K2 means K1 is much bigger than K2, and that means that B will produce in the reaction, and it will decay. The decay in concentration rate constant is very much less. So at a certain time B will present at that high amount in the reaction. Okay, at high amount. So it will have, we will get B maximum here, because K1 is much greater than K2, means it producing at a higher rate constant, or higher rate than that of it decaying, that at a lower rate the decaying rate is lower and producing rate is higher, because in this condition. But for this condition K2 is greater than K1, means K2 is much bigger than K1. So here we'll get, means K2 is greater than K1, means in this reaction, means at we can tell like this, that when at a time the condition the rate constant is greater than the decaying rate constant of B is greater than of producing rate constant, means that at a time it will, the decaying will be faster than the producing of B. So here we will get B minimum. Okay, for B max we will get a peak. For this condition, for condition 1 we will get like A, this is A, and here this is a B, because in this reaction we will get a peak, a maximum peak, and C will gradually increase of this one. So this is a condition of A. And for the second condition, okay, for the second condition K2 is, so here we can tell that, so here also this is a C, okay, so here it is A, but in this condition K2 is much greater than K1, so this one for B, because decaying rate constant is much greater than producing rate constant, and this one is for the C. So here we will get B max, here we will get B minimum. Okay, you understand that one? So now we'll, here we can say that here we'll get a peak for Q, okay, and B minimum, or just like S is a minimum peak for S. Okay, now Q will follow that this equation Q1 is greater than Q2, because it have a peak. So here Q1 is, means here K2 is greater than K4, because we get a peak here, so this option is correct. And another one, this one is like B minimum equation here, so K3 is greater than K1, so B option also correct. This is a MCQ type question, you have to do for all the, check all the options that is correct, and then you will get the that number of that question. Okay, so our next question that came in JAM 20. Okay, it's a tricky question. So a bacteria colony grows via cell division, and each mother bacterium independently produces 2 daughter cell in 20 minutes. Means this, if we, it's a bacteria, the concentration, initial concentration I am checking, this is A0. Okay, at 20 minute it will produce 2 daughters, so after 20 minutes it will produce 2. Okay, so after 20 minutes it also produce 2, from here it will 2, from here it will 2, so all total is 4. 20 minute, another 20 minute, it will produce 8, from here to here to, from here to produce, and from here it to produce, so total 8. Okay, now if the concentration of the bacteria is 10 to the power 4, then the colony becomes harmful. The starting from a colony with the initial concentration is 5 semicube, so A0 is equal to 5 semi per cube. Okay, the time taken for the colony for harmful, but our last means harmful is at a concentration of 10 to the power 4 semi per cube. Okay, you just have to know that what is the time taken for the colony to be harmful. Okay, so if it is A0, so we got 2 from here after 20 minutes, means 2A0. So after that, after 20 minutes, that is 4A0, 8A0. So we'll get a general formula, like, means I am saying after, if it is AT, I am assuming this is AT. So AT means from to reach at AT, means concentration at time T, we need that A0 into 2 into 2, from here it is 2, from here into 2, so that is 8A0, that is assuming as a AT1, because we let this one is 80, so AT1. So we can produce a general formula like AT at any time, it will be A0 into 2 to the power n. This is our general formula. Okay, n is, what is the n? Repeated times, means 1 here, 2 here, 3 here, so that is 2 to the power 3, that is 2 to the power 3, means after 3 repeated times it gets 80. So after 3 repeated times or n repeated times it will go, that is a t, from A0 to AT. Okay, but if it is 2, okay, the question is 2 daughter cells, it produced 2 daughter cells. If it is 4 daughter cells, so our repeated, here it's a 2 is repeating. For that, if it is 4, means from one mother cell it is 4 producing, then again after some time it's also 4, it's also getting 4 times, also getting 4 times. So then will be here 2 repeating, then the repeating unit is 4 there, that for that condition AT will be A0 into 4 to the power n. Means in question, how means the number of daughters cells will producing from the mother element, that is the repeating, that will be the repeating unit. Okay, so for our case repeating will be, unit will be 2. So our last means this is our, means 10 to the power 4 is our at we have to calculate the time for 10 to the power 4 as a AT. So AT is equal to A0 2 to the power n. Okay, AT is 10 to the power 4, that is A0. A0 is 5 initial concentration and it is 2 to the power n. So that is, if we do that, so 2 into 3 into 10 to the power 3, that is 2 to the power n. Now we take the log at each side, so n log 2 is equal to log of 2 into 10 to the power 3. So n will be log 2 plus 3 by log 2, because we know log of AB is equal to log of A plus log of B, or another thing, log of 10 to the power A, that is A. We have to know these two conditions. Okay, from if we calculate this one, it will approximate, it will go that is 10.96, n will be 10.96, that is approximately 11. Okay, so 11 repeated times means 11, so our total time will be, total time will be 11 into 20 minutes, because for each repeated time it will take 20 minutes. So our total time will be 220 minute. This is our expected result. So you just have to know the the concept, because we just have we produced a general formula for this question, and the what we studied that what will be the daughter cell that is produced from a mother cell, that will be our repeated unit. For 2, if 2 is daughter cell, so repeated will be 2. If anything 2, 3, 4, 5, anything will be that is our daughter cell, means that producing from our mother cell, so that will be our repeated unit. Okay, so next question. Okay, that came in jam 19. So our question is turnover frequency of for the catalytic reaction. Okay, the catalyst element is to 0.01 mole, that the initial concentration of A is 1 mole, and here is saying the 90% yield is product, yield of the product. 90% yield is 1 mole. The concentration of B will be 1 mole into 0.9. 90% is the reaction is over, so 0.9 mole is the concentration of B. Okay, so what will be our TOF, means turnover frequency. Okay, so our turnover frequency equation is TOF is equal to number of mole produced, number of mole of product produced by number of mole of catalyst used into time taken. Okay, the time is given here, that is 5 hours. Okay, so we just put the data from here. So product form is 0.9 that we calculated, and that is mole actually, and catalyst used at 0.01 mole into time taken, that is 5 hours. So mole cancel out, and that is 10. So 5 into 2, that is 18 hours per hour. Okay, these are answer. So next question is that came in jam 19. So the for reaction A plus B to the product. Okay, and the unit of rate constant, it asked about the unit of rate constant, that is, so our general unit form of means nth order. For nth order, the unit of rate constant will be unit of rate constant. Rate constant will be mole per liter to the power 1 minus n second inverse. Okay, we just need to relate with this one. So this is the given one, mole liter inverse second inverse. So mole that is the second inverse and the second inverse, that is same, but here mole means if it is to the power 1, so it will be same. So 1 minus n is equal to 1 from that equation, above equation. So n will be 0. N will be, if n is 0, so it will be equal to this one. So our order of the reaction is 0. It's a correct option. So our next question that came in jam 18. So time for 50% completion of zeroth order reaction is 30 minutes. Okay, it asked for the 80-minute time for the 80% completion. Okay, so a general formula for t half for nth order, that is 2 to the power n minus 1 by n minus 1 a0 to the power n minus 1 k n. So if it is n is equal to 0, so t half for zeroth order reaction will be 0 minus 2 to the minus 1 minus 1 by minus 1 a0 to the power minus 1 k0, that is half minus 1 by, or this minus will the lower minus will go upside, so it will plus, that is minus, so that is a0 will get upside and 0, so this will half, so a0 by 2 k0, that is t half. So we'll do 30 minutes. This is our equation for t half of a zeroth order reaction. So for, we know that 50% for it needed 30 minutes. So k0 will get from k0 from here, k0 will be a0 by 2 into t half is 30, so that is a0 by 60, that is k0. The unit is something mole that we got from here, the mole liter inverse second inverse. Okay, so our equation, what is, and our main equation for the zeroth order reaction is a at time t is equal to a0 at time 0 minus k t. This is our equation for the zeroth order reaction. So at is, that it means 80% completed. 80% completed means 20% is remaining, means at will be, means at is the concentration of a at time t, completed is 80%, so it will be 20% is 20% of a0 is remaining, so that is 0.2 a0. So 0.2 a0 is equal to a0 minus k0, that is a0 by 60 into t. So that will be a0 by 60 is t is equal to 0.8 a0. So a0 is cancel out, so t will be 48 minute, because minute is the equation, so unit, so here will be 40 unit. So for 80% completion we need 48 minute. Okay, this is our answer. So our next and last question of this today's last question. Okay, so that is the reaction A from the product and is a first order kinetics, and if A can represent the concentration of reactant, so at time t what is the incorrect variation, not the correct, there is the incorrect variation. Okay, so from A to product, that is first order reaction. Okay, that is given, and is initial concentration is, concentration is dependent on A0. So for, we know the rate of dA to dt, this is the rate of this reaction, that is depends on k1 A. So this is our rate equation. Okay, so from this if we derive, so our derivation at last result will get kt will be log of, sorry, kt will be ln at by, sorry, a0 by at. This will be our equation. Okay, ln or log is interrelated because so kt, this is a0 by at. Okay, so just a minute. Okay, so this is our first option, that is a is that the variation of a depends on t at time t, that is this. So this will be correct because this is the it's not a first order because it is a ln equation. So a0 of this one, okay, this is our a0. So ln, this is our a0 by at, and that is proportional to actually t. So this is a graph for ln. So this option will be correct. ln graph is this one. Okay, now DADT, this also will be type of this one because this is first order reaction, because this is also the type of this one, because DADT means rate of this reaction. This also, the reaction also follows this equation. So now option D is log A to log T. So what will be our log T? Means actually ln x is equal to 2.303 log of x. Okay, so if it is from here, we can say kt will be log 2.303 log of a0 by at. So it's asked about a. Okay, a is concentration of reactant at time t, means at, that is at means, okay, means kt is equal to 2.303 log of a0 by a. Okay, that is question. So if we minus kt or plus kt is equal to minus of 2.303 log of a by a0, that is the equation. So our, if we put our equation as a log a versus t, so this has a negative value. So we know that if y is equal to minus mx, so this will be our equation plus c actually. So this is also correct one because this have like this y is equal to minus mx x, from c will come from this one a0. If it is the log a minus log a0, it will get, so it will like, okay, I am solving this one for you. So kt will be minus of 2.303 log of a minus means plus 2.303 log of a 0. So this will our c, this is mx and this is our y, so it will give such equation. Okay, so this also correct. So our incorrect option is this one, because if this one correct, so this will be our incorrect one. Because why this is correct? Because this is a first order reaction. For first order reaction rate, because the rate will follow this one, not this, correct, because this follows this, the concentration of a means the concentration time t will follows this equation as a first order reaction, so it will also follow this reaction, this graph for as a time. So this for now, for this the end. So we did this question and we learned some concept this our, so what is the first question? This our t half for nth order. This are for direct questions. The second one, you just have to remember these equations only. Third question, you just have to do is with is your concept only. Second was little much, third was little much tricky, but it is easy if you do this. And for fifth one, this is the turnover frequency, and the other questions are easy. And this is some tricky, but it is also very easy if you know the equation for rate equation for first order reaction. So I'm ending this topic here. So if you liked my video or this video, so subscribe my channel and tap the bell icon if you want such type of videos in future, so that you can easily get it. Okay, thank you, bye bye.